Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us solve the problem on maxima and minima. In this maxima, they have given the rectangle box open at the top is to have the volume of 32 cubic feet. Find the dimension of the box required least material for its construction. This problem is based on maxima and minima. First, now let us represent the equation with respect to the cube with respect to a rectangle box. That is, first let us represent the solution. What they have given? They have given the rectangular box. Rectangular box contains the rectangular box contains length, breadth, height. Length, breadth, and height is represented by x, which is equal to length of the rectangular box and y represent breadth of the rectangular box and z, which is equal to, we have height of the rectangular box now they have given top has been open. Now let us first represent the given. Okay, volume, that is always volume is represented by x in length into breadth into height, that is x into y into z. Okay, which is equal to, what is 32 cubic feet. Considering this, now let us represent z, which is equal to 32 divided by x by y. This is the volume. Next, what we need to find the dimension of the requiring least material. To find the what material? The material required for the construction of what box? Rectangular box. Construction of rectangular box, that is given by box which is equal to 2 into length into breadth into height plus height into length. But in the given, what they have told, the rectangular box top is open. That means if I consider a rectangular box, assume it as a rectangular box, since the top is open, length and breadth will be rejected. So while constructing, let us represent this rectangular box, open rectangular box, that is S material which is required, S which is equal to length into breadth. We have reduced one length into breadth plus 2 breadth into height plus 2 h, that is height into length. Yes, now what is length is represented by x y plus 2 yz plus 2 zx. Okay, just represent or simplify, substitute z equal to 32 by xy. What we are going to get? Yes, which is equal to, we don't have z, we represent xy as constant, plus 2 into y. What is the value of z? 32 by xy plus 2x into 32 by xy. Y get cancelled, x get cancelled. Now S, which is equal to xy plus 32 into 2, we get 64. 64 divided by x plus 64 divided by y. Okay, now I need to differentiate s with respect to x and y. Differentiate s with respect to x and y. Okay, to differentiate x and y, let us differentiate, that is dou s by dou x, which is equal to differentiation of x. Y will be constant, differentiation of x is 1 into y plus 64 remains constant, differentiation of 1 by x, that is minus 1 by x square. Next, now let us differentiate, which is equal to, let's simplify this one, minus 64 by x square. Now, similarly, differentiate with respect to y, dou s by dou y, which is equal to y, x remains constant, differentiation of y with respect to y is 1 into x plus, here the, okay, this element will be 0 in this condition, where in this term we don't have y variable, so this becomes 0 plus 64 remains constant, differentiation of 1 by y minus 1 by y square, which is equal to x minus 64 by y square. To find the stationary points, we know that dou s by dou x equal to 0 and dou s by dou y should be equal to 0. Why? To find the stationary points. To find, okay, what is dou s by dou x? We have y minus 64 by x square, which is equal to 0, and x minus 64 by y square, which is equal to 0. Y, which is equal to 64 by x square, comma, x equal to 64 by y square. Now substitute x in y. Okay, substitute this in with respect to y. What we are going to get? Y, which is equal to 64 by, what is the value of x? 64 divided by y square, the whole square, which is equal to, we can cancel 64 1, that is denominator, okay, we get 1 by 64 by y square, the y square, y power of 4, that is denominator of the denominator goes to numerator, y power of 4 divided by 64, y get cancelled, y cube equal to 64, y which is equal to cube root of 64 is 4. This is the value of y. If you, since we have got the value of y, substitute y equal to 4 in x, that is x which is equal to 64 by 4 square, that is x equal to 4. Okay, this we call it as the stationary points. Stationary points of x comma y, that is 4 comma 4. To find whether the given points have locally minima or locally maxima, we have the condition, that is a which is equal to dou square s by dou x square. This is the first condition. Next, b which is equal to dou square s by dou x dou y. Next, the another last condition, that is c which is equal to dou square s by dou y square. Okay, now we need to show that d which is equal to ac minus b square, we need to find this condition. So let us find a, c and b. First let us find a, that is equal to dou square s by dou x square, That means considering dou s by dou x, differentiate dou x by dou x again with respect to x, that is y minus 64 by x square. Now differentiation of y with respect to x, 0 minus 64 remains constant. Differentiation of 1 by x minus we have taken as constant, that is 1 by x square. Differentiation of 1 by x, how we need to do? Let us consider, let us represent 1 by x square as x power of minus 2. We know that differentiation of x power of n is n into x power of n minus 1. Now, what is the value of n? We have minus 2 into x power of minus 2 minus 1, which is equal to minus 2 x power of minus 3. This can be written as minus 2 by x cube. What? Minus 2 by x cube. That is minus 2 by x cube. Minus 2 by x cube. Now minus into minus, plus 64 twos are 128 divided by x cube. Now since we know the points, that is x equal to 4, substitute x equal to 4, that is 128 divided by 4 cube. If you go with 4 cube, we get 64. 4 cube is 64. 128 by 64, which is equal to 2. What is the value of A? We have what? 2. Similarly, let us find B. B, which is equal to dou square s by dou x dou y. Considering y, I am going to differentiate with respect to x. That means considering y, this term, and differentiating with respect to x. What we are going to get? Considering this is the term what we are going to differentiate with respect to x. That is differentiation of x is 1 minus, since we don't have any term with respect to x, this term becomes 0. 1 minus 0, which is equal to 1. This is the value of B. Similarly, let us go with respect to C, that is dou square s by dou y square, which is equal to, again differentiate this y with respect to y. Again here, since we don't have y, this term becomes 0. Minus 64 remains constant. Similarly, how we simplified x square, 1 by x square, we can represent the same function with respect to 1 by y square, that is minus 2 by, instead of x cube we get y cube, which is equal to 128 divided by y cube. Since we know the critical point or the stationary point, that is y equal to 4. Y equal to 4, which implies 128 divided by 4 cube. That is, what is 4 cube? We get 64. 128 divided by 64, which is equal to 2. Since we have got A, B, C, just simplify in D. That is, D is the standard condition. That is AC minus B square. What is the value of D? Which is equal, what is the value of A? We have 2. What is the value of C? We have 2. What is the value of B? 1 square. D, which is equal to 4 minus 1. D, which is equal to 3. Now we need to conclude whether the given function is either what, locally minima or locally maxima. To find that one, we have the condition, that is if d greater than 0 and a greater than 0, we call it as locally minima. Now let us check, since d is also greater than 0 and a is also greater than 0, we call it as, therefore the function is local minima. This is the conclusion. Now, since they have asked to find the dimension of the required least material, that means the dimension. What are the dimension? That is x, y, and z. To find x, y, and z, we have x, y. Now let us simplify. Now let us find the last value, that is height, that is equal to z. What is the value of z? We have find the value of z. Where is z? here. This is the value of z. If I simplify the points x and y, I will get the value of z. We know that z, which is equal to 32 by xy, where x equal to 4, y equal to 4. Z, which is equal to 32 by 4 into 4, that is 32 by 16. 16 ones are 16 twos are. What is the value of z? Z value equal to 2. Therefore the okay, I think there is you are not able to see. I'm going to erase this part. Okay, that is, okay, let us erase this only. That is, therefore the dimension of the box requiring least material for its construction is x comma y comma z, which is what is the value of x? We have got 4. What is the value of y? We have got z is 2. This is the required dimension to construct a rectangular box when the top is open, that is 4 comma 4 comma 2. I hope you have understood this problem. For any doubts, please do subscribe, like, share, and see you in the next video. Thank you.